NASA's James Webb Space Telescope has hardly opened its eyes, yet the universe has already become more mysterious, more beautiful, and more astonishing than humanity's greatest dreams. Webb has captured images so shocking they might rewrite the rules of the universe itself. For decades, we thought we understood how galaxies and stars formed. But this new discovery flips that understanding upside down. Could this be the moment we realize that everything we've been taught might be fundamentally flawed? Let's delve into the images and discoveries that challenge not only our comprehension of the cosmos but also our place within it. For decades, the Big Bang theory has been the cornerstone of modern cosmology, built upon observations of the cosmic microwave background radiation, CMB, a faint afterglow from the universe's birth. Discovered in the 1960s, the CMB has been regarded as a snapshot of the infant universe, providing clues about its expansion, density, and age. But as Webb's sharper eyes examine the universe, it's becoming clear that we might have misread this so-called snapshot for decades. The truth behind the CMB is proving to be far more unsettling than anyone dared to believe. Webb's findings also highlight the Hubble tension, a long-standing discrepancy between two methods of measuring the universe's expansion rate. One method, based on the CMB, suggests a slower rate. Another, relying on observations of supernovae, indicates a faster rate. Now, Webb has identified galaxies so old and well-formed that their existence defies the Big Bang timeline, turning the Hubble tension from a red flag into a full-blown crisis. One of Webb's most astounding discoveries is the observation of galaxies that seem to predate the Big Bang itself. How could something exist before time supposedly began? These ancient galaxies challenge the very fabric of cosmological understanding. If they are as old as they appear, the Big Bang theory might need to be replaced entirely. Scientists are now questioning whether we've misunderstood the CMB, the expansion of the universe, or even the nature of time itself. This isn't the first time science has had to eat humble pie. Newton's laws of motion and gravity once seemed to explain everything until Einstein's theories showed that space and time are more fluid than we thought. Now, Einstein's theories themselves are hitting limits, especially when it comes to understanding dark matter and dark energy, the mysterious substances that supposedly make up 95% of the cosmos. Webb's data makes these components look even more dubious. Dark matter and dark energy have never been directly observed. They were invented to patch holes in our models, much like a band-aid covers a wound. But what if these substances don't exist at all? Webb's findings suggest that the universe's behavior might be explained without them by tweaking existing constants or embracing entirely new theories. For instance, some scientists propose that gravity might work differently on cosmic scales. If that's true, our entire understanding of physics could be upended. Another area where Webb is shaking things up is with redshift, the phenomenon used to estimate the distance and age of celestial objects. For decades, redshift measurements have been treated as gospel. The further a galaxy's light is shifted toward the red end of the spectrum, the farther away and older it's assumed to be. But Webb's observations challenge this assumption. Some galaxies appear far older and more massive than their redshift suggests, raising the possibility that our calculations have been wrong all along. Webb has also unveiled a vast cosmic web of galaxies and filaments that defies current models. These structures are far more organized and mature than they should be, given the supposed age of the universe. It's as if we've stumbled upon a fully built skyscraper in a city that's barely begun construction. How did these galaxies form so quickly? The answers remain elusive and fundamentally unsettling. The impact of these findings is rippling through the scientific community. For some researchers, Webb's discoveries are a call to arms, an opportunity to develop bold new theories. For others, they're a source of existential dread, as lifetimes of work are called into question. Imagine spending decades building a model of the universe only to have a single telescope render it obsolete. That's the reality many astronomers face today. Consider the material composition of these ancient galaxies. Webb's spectroscopic abilities have revealed chemical fingerprints suggesting that elements like carbon and oxygen existed far earlier than anticipated. This implies an even earlier generation of stars that lived, burned, and died, forming these elements before the observed galaxies could exist. This timeline completely contradicts the framework we have relied on for decades. Moreover, Webb's data raises questions about the fundamental nature of light itself. Scientists have long depended on light's properties to draw conclusions about distance, age, and motion. But Webb's findings suggest there might be subtle, previously unnoticed shifts in how light behaves across vast cosmic distances. If our assumptions about light's behavior are incorrect, every measurement we've made, from the size of the universe to its age, may need to be re-evaluated. Webb's observations also hint at the significant role of neutrinos, ghostly particles that can pass through entire planets without interacting. These findings suggest neutrinos might play a far greater role in cosmic evolution than previously thought. Similarly, Webb's discovery of high-energy phenomena in distant galaxies raises questions about the processes fueling them. Could these be evidence of entirely new astrophysical processes, or do they reveal flaws in our understanding of star formation and black hole activity? Webb isn't just rewriting the history of galaxies, it's also turning its attention to exoplanets, worlds orbiting stars beyond our solar system. One such exoplanet, K218b, has sparked intense debate. Located about 120 light-years away in the Leo constellation, K218b is believed to be a Hycean planet, a hypothetical type of world covered entirely in water. Webb's observations revealed the presence of methane, carbon dioxide, and possibly dimethyl sulfide, DMS, in its atmosphere. On Earth, DMS is produced by life forms, specifically by microorganisms in the oceans. If confirmed, this could be the most compelling evidence yet for extraterrestrial life. Ultimately, the James Webb Space Telescope is more than just an instrument, it's a catalyst for change. By forcing us to confront uncomfortable truths about our models and assumptions, it's pushing science forward in ways we never anticipated. The universe, as revealed by Webb, is a place of endless wonder and complexity, a stark reminder that, in the grand scheme of things, we're still in the early days of understanding the cosmos. The path ahead will be challenging, but it's one we must embrace with open minds and a willingness to question everything. The Hubble Space Telescope, once the crown jewel of space exploration, paved the way for these discoveries. In 2012, Hubble's extreme deep field image gave humanity its deepest view of the universe, capturing light from over 5,000 galaxies as they appeared nearly 14 billion years ago. While breathtaking, Hubble's capabilities pale in comparison to Webb's. Webb's near-infrared technology allows it to see objects 100 times fainter and farther, offering an unprecedented glimpse into the universe's infancy. Webb's discoveries are not just changing how we see space, they're also making us think differently about life and our place in the universe. The universe is not a neat, predictable system but a vast, bewildering question that will keep us guessing for generations to come. Whether Webb's findings lead to a new golden age of astronomy or plunge the field into turmoil, one thing is certain: the universe